Okay, here we go. IB Math students, here is a little helper video to help you with Chapter 3H in the HL curriculum. So this is our introduction to vectors. So hopefully you have watched the other introductory videos already because I really liked the first video. Even though the graphics were really messy, I thought he had a really great way of explaining what a vector is, how that it's a shift. And the way that we write the component form of a vector, hopefully that looks familiar to you because that's the same way that we write a translation when we're graphing a function. If we want to translate it, we write it as in vector form. So it's really a shift. So notice here I have some vectors, and notice I did not put a coordinate grid on these vectors because I want to give you the idea that vectors can be moved around anywhere on the coordinate plane. What's important about vectors is their length and their direction. So as you can see, vector A here has a length of 3 units. Since I didn't put any kind of coordinate grid on here to imply any other type of unit, we are just going to be counting each grid section as 1 unit. So A is in the y direction and it's going down. See the little arrowhead? So vector A, and when you're writing it, we tend to put a little arrow on top. So you can see it this way, written with just half an arrowhead. That's one way of writing it. If I had put letters at the endpoints here and here, then we could have referred to it by those 2 letters with an arrow over it, and you'll see that in our textbook. But oftentimes vectors are just referred to by a single letter. In a textbook, that letter might be in bold, but it's kind of hard to write a letter in bold when you're putting it in your notebook. So we put a little sort of half arrow on top of it. So in the first video we saw, he put like the arrow on underneath it. So notation can change. So depending on what country you're in, what textbook you're using, the notation can change. But the way that we write the component form is going to stay the same. So this vector is showing no left or right movement. So the top number is going to be 0, and it's going down 3 units. So this is our component form. We can also write it using I and J. So I goes with the X direction and J goes with the Y direction. So this would be 0I, and that's an italic I, minus, because it's going down, 3J. So it's saying that I'm moving 0 units in the I direction, which would be to the right, and 3 units down, because of minus, 3 units down in the J direction, which would be Y. Okay, so these are 2 ways for writing this vector A. So this is actually question number 1 from chapter 3H. It asks you to write the component form. Let me see, what's the actual, write the following vectors as column vectors and using I and J notation. Okay, so here it is written in column form, and here it is using I and J. Now, if there's no I's, you can abbreviate this and say that that's just equal to negative 3J. Okay, so since it's 0 I's, you don't have to write the I's at all. All right, vector B, as you can see, it's going down this way. And so to go from the tail to the head here, and let me see, am I calling that correctly? Sorry, I'm not going to look it up right now. You can correct me from the videos if they use different words. But if you're going from I would say the tail to the head. If you're going that way, notice I have to go 2 to the left, and then I have to go 2 down. So this one, vector B, is going to be equal to negative 2 because I'm going 2 left, and then negative 2 because I'm going 2 down. Now, is that the same as going 2 up and 2 to the right? No. Okay, so in this case, it looks like a negative divided by a negative, but no, you can't do that because the direction is clearly going down this way, going down to the left. So the component form here, it's 2 to the left, so negative 2, and 2 down, negative 2. You can't write this as positive 2, because that would change the direction of the arrow. The arrow then would have been pointing up to the right. Okay, so this is negative 2, and if we write that in with the I and the J, it would be negative 2I minus 2j. Okay, so it's just a different way of writing it. Okay, all right, the next one, vector d, you can see the little arrowhead is here. So starting from the tail, moving to the head, it's 1 to the right and then 3 down. So vector d is going to be 1 to the right and then down 3. And if we put that in our ij notation, that would be 1I, or you don't have to write the 1, you could just write I minus 3j. Okay, and C over here, notice it's going up 1 and to the right 2. So vector C is equal to 2 to the right. Sorry, I should do my left right first if I'm writing that in first. 2 to the right and then up 1. And of course, you could say 1 up and to the right, but remember the up down goes here. This is where the y direction goes and the x direction here. Okay, and so this would be 2I plus 1j. Oh, and sorry, I was going to go back here. 1I, you can just write it as I, just like 1x can be written as x. Okay, so I, 3j. And same thing here, 2I plus, I don't have to write the 1, I can just write j. Okay, oh, and I got one more, letter E over here. So this one, letter E, is equal to, I'm going 2 to the right, and I'm not going up and I'm not going down. So that would be 2I plus 0j. Since I don't have any j's, I don't have to write any j's. I can just write 2I. Okay, so thinking about how the first video talked about it as a shift, it really doesn't matter where these are on the coordinate plane. Okay, so I could pick up this little vector and I can move it around. As long as I keep it the same length and going in the same direction, I can move it around. All right, another thing we can do is what's called scalar multiplication. So scalar multiplication, you're going to see this a little bit. Multiplication. So what if I had vector b, and I said I want to scale it. I want to do scalar multiplication on it. I'm going to by the number, I want it number 3. So that means I have 3 of those vectors, and I'm going to put them end to end. This is the same thing as saying I have vector b plus vector b plus vector b. Okay, so just like combining like terms, b plus b plus b is equal to 3b. So when you add your vectors, as you saw from the videos, you're going to put them tail to end, tail to head. Okay, so they're going to line up. So if I start with my vector b from up here, it's going to left 2 and down 2. So it's going to go right there. Then I put another one starting at the tail to the head, to the left 2, down 2. And the next one. Okay, there's the third one. So here's B, B, and B. And I just hook them all together. Whoops, I'm off the edge of my viewing area. Sorry about that. Got too many things in the way. So this makes a new grand vector here. Okay, so if I'm going to go ahead and just copy it over here. Because remember, I can just pick it up and move it. It's still the same length. And now this vector is 3b. Okay, this is vector, it's 3b long. And notice how far is it moving? So it's down 6 and to the left 6. So 3b is equal to, it was down 6 and to the left 6. Okay, so now notice the original vector b, if I write it in component form, was -2, -2. And look what happens if I just say 3 times that. How would I get -6, -6? I would just multiply both the x direction and the y direction by 3. And so that would give me -6, -6. Okay, it gets the same answer. So vector addition and scalar multiplication, super easy, all right? So the videos should have explained how easy vector addition is. You just add the x's and you add the y's. And scalar multiplication, again, super easy. Just multiply all the components by the scalar. And hopefully that'll get you through the assignment. The other thing that I wanted to point out is parallel. When vectors are parallel, I want you to think about parallel lines. When do we know lines are parallel? What has to be true about lines being parallel? Right? They have to have the same slope, okay? And what is this? What is this? If I have -2 over -2, -2 divided by -2 is +1. Doesn't this, if I said this was a line, doesn't this line have a slope of 1? And this has a slope of 1, and they are parallel to each other. So you can think in terms of vectors being parallel to each other as if you change them to lines, would they have the same slope? All right, so that's one way to think about it. So if you were to change the vectors to lines, if you were to think about them as lines, they would need to have the same slope to be parallel. So vectors can be parallel to each other, right? And they just need to have the same slope. So think about how you would calculate the slope for a line, and you can just look at them, just inspect them, rise over run, okay? If they have the same slope, it doesn't matter if they're going in the same direction. It doesn't matter if the arrowhead is facing the right direction, in the same direction. It's really that sort of that slope business that makes them parallel or not. All right, so that's your helper video. Good luck. See you later. Bye-bye. Oh, where's the stop button? I always lose it. There it is. Bye.